Hello, welcome back to Blender CC Live Learning. In this episode, I want to talk about the transform geometry in Blender geometry nodes. Transform geometry apparently comes with two flavors. The first one is components, and I didn't realize we also have matrix, and we are able to use combine transform nodes as a matrix input for the transform geometry, and we can actually transform geometry that way. So in the past, if we are talking about like an array of grid of cube, normally I just think about, okay, we already have a grid node, right? Grid node will create a mesh, and then if we turn it into mesh points, mesh to points, we're gonna have points, and we can instance our cube into this guy. Okay, instant on points. So we got the points, we have the grid primitives, and we can just instance bunch of cube on top of that, so we know the drill. We just need to play around with the numbers, and we get a 2D array of grid. Okay, so that's the one way to do it, but I have down here another setup, a different setup using matrices and transform geometry, and I have repeat nodes happening twice. So you probably know already, if you have like a cube, and if you duplicate it a couple of times in one axis, so you're doing that by selecting a cube and then Shift D, and then you use G, and then actually like constrain it into one axis, and then Shift R, repeat it multiple times. And if you do it the same, you do the same thing, like duplicating and repeat the same time, you get a array of grid of cube. Okay, so that's one way to do it manually, but now we are doing it using geometry nodes and transform geometry, and also the matrices. You can also use the components, but I just want to show you with combined transform matrices, we can do a little bit more, because matrices have some more nodes that's dealing with all this matrix stuff. Yeah, if you don't understand any of these nodes, you probably can use Meta AI to do it. Just ask what is it all about, and then figure out the nodes functions. But yeah, the reason I want to talk about this, because the other day I saw this tutorial by MTR Animation. This is actually really good, really good tutorial already. I don't need to repeat this tutorial. I just want to try it myself. So it's showing you how to create a flower and the blooming flower. So it's really already beautiful tutorial. Half an hour. Take a look at this one. But I just want to talk about it myself, so the way I understand it. So we can use repeat, right? Repeat node, and so the default cube can go inside repeat, and then in this case, so let me zero this out first. I want to translate this cube maybe 3 units, and I want to repeat it 3 times, so we get 4, the number here equal the number here plus 1 original geometry. That if you use join geometry inside repeat nodes, we know that it's gonna be like a duplicate, and it's gonna do a repeat multiple times depending on this number. So this is how we can create an array of cube if you were to use the transform geometry. Same things. So we can just use translate, and if we try to use rotate as well, you can see the effects kind of doing it multiple times to the cube. So you can have this really interesting effects happening, and you can also try to play around with the scale. You might notice something very quickly, that's the the order of rotations also, the order of matrix transform will affect the final result of the transformations. Yeah, maybe not so clear at first, but yeah. Okay, you also notice that Blender just frozen on me because maybe it's probably taking too much memory, because what's happening is you might need to convert the geometry into instance before you do anything. If you are doing a lot of matrix transformations, it's a good idea to just convert the geometry into instance beforehand. So shift right click, and then geometry to instance. Probably this will make things a little bit faster. Okay. Okay, rotation works. I can rotate that way. So I can make a spiral, something. Yeah, I could basically make like a donut shape. Yeah, I think it doesn't quite like that one. So let me start again. Or instead of using cube, I will show you another example that's actually using Suzanne. But my point, first of all, if you want to play around with the transform node, so transform geometry. So like I said, it comes with two type components and the matrix. With the matrix, you have this transform matrix node input, but with this one you have translate, rotation, scale. And my point with this, first of all, the order of transform matters. If you, for example, if you translate this in Z, put it on the floor, 1 unit, so it's going to be on the base. And then if you scale here and then you rotate, you can then create duplicates that way. Imagine this is like a petal of flower. But if your order is a little bit wrong, or if you for example scale first and then you translate or you rotate here and then you do the scale later, you're gonna have like skewing happening. So order of transform matters. First of all, that's my point, and then I will show you some example. Spiral Suzanne. Okay, this is if we were to use a spiral mesh geometry to instance Suzanne, we can get spiral very quickly and easily. But in this case, we want to use transform matrices. So that's kind of cool. This looks like a kind of like a dragon, the monkey that's become dragon, sort of. If we were to use the transform matrices, it's gonna look something like this. Okay, maybe I have too much data here. Oh yeah, I have 2000 Suzanne here. Maybe make it 100. Yeah, all right, let's take a look. View, select check. Okay, here, so you can see I am using geometry to instance. If I don't use this 1000 Suzanne, and my Blender already gonna crash, but because I convert it into instance and then do the repeat, I can have higher number here and Blender will still run properly. So in this case, I have this cube. This is a simpler example. So the cube, I put it on the base like what I did earlier, and then I scale it, and I can make another translations. If it's like a flower petal, it's not at 0, 0, 0. I translate this a little bit further. I can still play around with the scale here. So this is the original set up for the like a flower petal, for example, and then I can use loop and then repeat it multiple times. And inside the loop, I use the transform geometry matrix and rotations. The rotation, I could make it slightly random if we have integer value plug into the ID, and then we have this random value and we want to rotate the petal certain number and then just randomize the seed. So this goes into combined transform, which will convert this 3 value translate rotation scale into matrices, and then so we can have flower petal. I think, yeah, I think that's the case here. So the same thing happens for Suzanne. I just need, with Suzanne, I need to make some modifications because Suzanne head is not like a cube. It has different unit size, so I have to maybe adjust the Z. I can control the scale here and extra offset for Suzanne head. So I'm creating a duplicate of Suzanne head without using spiral geometry. I'm simply by repeating the transform matrix and then applying it to Suzanne, like so it's doing the duplications and repeat of matrices. So I can actually go inside and you can see it's like a sunflower. For some, I think if we are using instance and vector, it's gonna be simpler and probably more efficient, but transform geometry and matrix actually really useful in some other cases. Yeah, before we don't actually have these nodes before, so I'm still testing this out. Translate, this is the offset translate. So by translating and rotating, we get like a spiraling happening. It's like a DNA, but from this point, it looks like a little bit like flower. You can of course do multiple, you know, after you rotate again, and I don't know, because it's doing it multiple times, so you might get a donuts in the end. Yeah, so matrix transforms. I want to show you another example where the result is slightly where is it? Not this one, not the spiral. Okay, this one I think. So if your order of operation of the matrix is slightly different, you get the sharing happening. Although this is probably not what you want, but still kind of interesting to see this happening. By the way, be careful when you are doing instance. Make sure you bring in the original geometry into join geometry here. Do not do this. Okay, it might repeat itself and Blender might crash, but this is probably what you want. And then just in case, geometry to instance, you probably need this, so it's gonna duplicate much faster. So here it's just doing duplications. Maybe I I shouldn't scale, but if you want to do scaling, do it outside of the loop, do it outside of this repeat node, so you can have what I have earlier, something like this. Okay, put it on the base, put the cube on the base, and then scale it. If you want to have offset, do the offset after, and then the rest, if you want to do other scaling, do it inside the repeat node. Oh, like, yeah, rotation and scaling. But I really think this video is really good already. I probably need to study it myself. So this one explain how to create a petal perfectly, beautifully. It's like, I think 10 years, I think this can be done inside Houdini as well, but I think because now we have Blender to do this, Blender and geometry nodes, it's just beautiful to be able to do this just inside the blend files. So anyway, that's how I try to understand this matrix and transform geometry stuff. Still, I still recommend this video. Watch this video. Maybe it will explain a little bit more, but I just want to try it myself, and maybe I'll figure out something else. And this is just a simple basic examples. So it's all in the matrix. If you want to dig inside, like further, there's extra matrix node in here, like invert matrix. What is invert matrix? If you don't know, you ask like something like Meta AI, and then give example. What is invert matrix node is used for? Reverse transformation, calculate normal. Yeah, and you give example of something. Yeah, but I think it could be really useful there. Blender and AI should be useful for you to understand things a little bit faster. Anyhow, so that's transform geometry and matrix. Hopefully, like basic example. Hopefully you find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.